Hi friends, welcome back. Today we are going to solve another very important and interesting Microsoft coding interview question. It's on Leetcode 934 shortest bridge. As you can see here from the like dislike ratio, this is another quite likable and frequently asked coding interview questions of medium complexity. So this is a matrix related coding problem. So we are going to go through this problem, understand this problem with some examples, and we are also going to implement our Java solution code. If you haven't already subscribed to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, Java programming and coding. So let's start. You are given n by n binary matrix grid where 1 represents land and 0 represents water. An island is a 4-directionally connected group of ones not connected to any other ones. There are exactly 2 islands in grid. You may change zeros to ones to connect the two islands to form one island. Return the smallest number of zeros you must flip to connect the two islands. Okay, so this is what the problem says. So we'll go through the examples. Constraint says that the grid dot length and grid I dot length is n, which means that it's a square matrix and square matrix size will be between 2 to 100 inclusive. So maximum matrix size can be 100 by 100, which is pretty big matrix. Grid ij is 0 or 1. It's a binary matrix. There are two islands in the grid. Okay, so this is what the problem says. So let's understand this problem with one example that I created for you. So this is one of the grid that is given to us, right? So what they are saying is, so first let's understand what the 4-directionally means for the people who doesn't know it, right? So I'll just quickly explain them. So it will be more clear for them. So let's say this is your matrix, right? Let's say this is your matrix, okay? So just draw something so I can write down something here, and these are your columns, right? Okay, so you have a columns. So let's say you are standing at this position I comma j, right? You are right now here. So the 4 directions which are connected to this cell is I minus 1j, right? So this is up, basically up, right? Down means I plus 1j, correct? And right means I j plus 1, so this is right, and I j minus 1 is left, correct? So these are the 4 possible connected cells for this cell. Basically for this cell, these are the 4 possible connected cells. Okay, so this is what the 4 possible connections means: up, down, left, right. Okay, so now you understood that 4 possible. So now what they are saying is they have given us a binary matrix like this one, for example, and there are 2 islands in this matrix, exactly 2 islands. So how do we know that 2 islands? Because islands are formed by using 1. So like this, so this is one island basically, right? So this is one island. Okay, where is the second island? So second island is here, right? So this is the second island. So this is the second island. Okay, so these are the connected ones, right? Okay, so what the problem is asking us to do is we want to connect these 2 islands, right? So you can connect these 2 islands like this. I can convert these zeros to all ones and they will be connected, right? Or I can take these zeros and they will be connected. So if I do this, how many zeros I will be converting? 1 2 3 4 5 6. So I'll be converting 6 zeros here to ones, right? And then I can make the 2 islands connected. If I take this for example, I'll have to convert these 4 zeros into ones, right? What they are asking us to find out is the minimum number of zeros we want to flip. So where that minimum number of zeros will happen? Here, for example, right? This is one place where the minimum number of zeros are 3 that I can flip and I can connect both these islands, correct? Or I can also do it here, right? So this is also 3. So but less than 3 is not possible, so it should be equal to 3. That is the smallest bridge that we can connect we can build to connect these two islands, right? So that's why the output is 3. So you understood the problem now? Okay, so you understood the problems. How can we solve this problem? So to solve this problem, we'll use very famous and popular matrix related technique to solve this kind of problems, which is BFS, right? BFS stands for breadth first search, breadth first traversal, also known as level order traversal. BFS uses queue, right? BFS uses queue. We will also use a queue, right? And whenever we see a 1, we are going to add that 1 into the queue, and we will also keep track of the distance, right? Distance of the cell from the current island, right? Correct. So in this case, what we will do, we will, instead of using queue, we will use a priority queue here. Why we use priority queue? Because we want to always keep track of the cells which are at the least distance from this cell, right? For example, what is the least distance means? For example, this is a cell. Let's say I start with this one, because we know that 1 is a part of island, right? So there are 2 cells that I can go here, right cell and down, because of the 4 directions that I shown you here, right? So you will go these directions and you will add these cells into the priority queue. So you add 1 and 2 cells into the priority queue, but at the same time you are also adding the distance of that cell from the current island. So distance of this cell from current island is 0 because it is part of the island. Distance of this cell from current island is 1, correct? What does distance means? It means that how many zeros I have to flip, because this is a 0, right? So I'll calculate it as a distance. Okay, next time you will take this 0 out of the priority queue, you will go here and you will also go here, correct? 4 directions which are not already visited you will go, correct? Here also your distance will be 0, here also your distance will be 1. Why 1? Because 0 is the distance basically, right? Means you have to flip 0. 1 is a part of this island, so you don't have to do any flip, correct? Okay, so you will always get the cell which has a least distance basically. That's why we will use priority queue. Priority queue, we will use it as a uh, min heap here, where we will use it as a least distance you will always get. So you will have multiple cells in that priority queue, but whatever cell gives you the least distance, you will consider that cell, correct? You understood, right? So for example, you have all these cells. Now you will keep adding all these cells into the BFS, right? So like these cells, you will keep adding it. But whenever you remove the cell, you will always remove the cell which has the least amount of distance, right? So least distance, correct? Least distance. And why that least distance? So that we can build a shortest bridge. We want shortest bridge, and in another term we want to flip shortest number of zeros, correct? So when you go from this cell to this cell, your distance will be 1 here. When you go from here to here, your distance will be 2. When you go from here to here, your distance will be 3, for example. Now very important, right? Now very important thing, when you are actually going from this 0 to this 1, right? You are seeing a 1 which is a part of another island, correct? You are seeing this one which is part of another island. How you will recognize? Because the distance here is not 0. It means that you have some zeros in between these two islands. It means that this is a separate island, right? Once you reach a cell of a separate island, this distance of this cell, right? This distance will tell you the shortest bridge that you want to form, so that these two islands will get connected, right? So 3 is the answer basically. You got it, right? So this is how BFS will work here, right? So even if you have other cells, let's say you also go from this side, so you will stop at the third cell, right? You will not go to this fourth cell, because BFS works like that, right? BFS, we are using priority queue, so it will choose a cell with least distance first, correct? Least distance first. So this is the place where you will have least distance here, right? This one or this one, right? So other cells will also keep expanding, but they will only this cell will reach first, because this is the shortest distance between two islands, right? That's why we use BFS to solve these kind of problems. Correct? You understood, right? So I'll remove all these colors. So what I mean to say is, one more time I'll explain you. So you keep expanding in all the directions, four directions I mean to say, right? So you, let's say you are expanding from here also. This is a 0, 0, 0. You expanded here. Here also you expanded from here, right? 0, 0, 0. Correct? Now when you expanding to other cell, right? You might go from here to here. So this is also possibility, right? For you, you might go from here to here also, correct? So you will always reach to the second island in the shortest time basically, or shortest number of zeros basically, correct? Here you did not reach the second island, right? If you are going from this side, let's say this side, for example this side, you are here, then you second is this, third is this, right? So you can go from here to here fourth time, right? But you did not yet reach the second island. This is the place, or this is the second place which will, because there are also three zeros here, right? Where it will help you reaching the second island first. Okay, it will help you reaching the second island first, right? Other cells will reach later. That's why this is the shortest path between two islands. Okay, so this is the basic idea and logic to solve this Microsoft popular coding interview question, shortest bridge. So I hope you understood this logic clearly now. So now let's go ahead implement this same into the code. So to calculate, to keep track of the cells and distance, we will create one Java static class like this one. So this is our Java static class. We'll call it as a node. This is implementing a comparable interface. So node implements comparable interface, which means that it has to implement the compare to method. So this class has three fields. Ij is the ij coordinates, which is a row and column coordinates of the cell, and distance is the distance basically. I explained you, right? Distance is number of zeros basically in between the two islands, correct? So this is the constructor of the node class, and this is how you will implement the compare to method. So the compare to method, what you are doing here, -1 multiplied by integer dot compare to n2 dot distance comma this dot distance. So it means that in the priority queue, when we have multiple node objects inside the priority queue, it will give you the node object which has the least distance, correct? Which has the least distance, right? Okay, so this is the so before we start looking the further details, I'll quickly go to the priority queue class. So this is what we are going to be using here now in this code. So priority queue is in the java.util, another very popular Java collections framework class, right? So as you can read here, an unbounded priority queue is based on a priority heap. The elements of priority queue are ordered according to their natural ordering or by the comparator provided at a queue construction time. So we have actually, we did not provide the comparator, but we implemented comparable interface, correct? So either way is, you can do it in both the ways. So this priority queue class has a couple of important methods here. I would like to quickly show you once, and then we'll go to the code because they are discussing more about the time complexities for those methods. So let's take a look here. So this implementation provides log of n time complexity for enqueuing and dequeuing methods offer, poll, remove, and add. So these four methods are important frequently used methods: offer, poll, remove, add. To add something into the priority queue or remove something from the priority queue, it takes log of n time. Okay, fine. Now linear time will be taken for a remove object and contains object method. Okay, so the remove object and contains object method takes order of n time. Okay, and for the other methods it takes constant time, for other in the sense pick element and size methods, right? Okay, so this class got introduced in JDK 5. So these are the overloaded constructors of priority queue class, as you can see here. So these are the methods which are frequently used: add method, offer method, these will add to the priority queue. Pick method and poll method will give you the front element from the priority queue or the head element from the priority queue. The difference between pick and poll is that the poll method will also remove it from the priority queue, right? It removes the head of the queue. Okay, so these are the couple of important methods. So go through all this documentation. Whenever you want to use a class for need a class for min heap, max heap, then priority queue is a very useful and handy class in Java. So make sure you know this class well, right? So today also we are going to use this class. So now you understood this node class, right? That now we'll go through our main code. So grid is given to us, which is an integer array. The name of the method is shortest bridge. This it returns integer, correct? The how many zeros, minimum number of zeros we have to convert to one so that we can connect those two islands is what we will return. So we'll create a priority queue here which will hold node objects, correct? And these directions are basically to go in 4 directions, right? So these are the 4 directions I already mentioned here, right? So we have to go in 4 directions, but we also have to make sure that the 4 directions should be within the boundary of the matrix, correct? It should be within the boundary of the matrix. So what I mean to say by that is, if you are at this one, you cannot go here, right? This place is not valid, this place is not valid, right? Because it's outside of the boundary of the matrix. So found is false in the beginning. This is a boolean variable. We'll start looping through the nested for loops. We'll keep traversing through the um, given matrix, 2D matrix, until we find out a first one, right? So I is 0, I is less than grid dot length I plus plus, j is 0, j is less than grid 0 dot length j plus plus. So grid ij is equal to 1. It means that you found the first one, correct? So that's what we want to find, because that will give us the first island point basically, right? That is what we want to find first. You will add that first island point ij and its distance is 0, correct, from the first island, and you will mark it as a -1 because you now already have processed that point in the matrix. So you will convert it into -1. Okay, and found is equal to true because you found out the first island. You break out of this for loop, right? And you will break out from this outer for loop also, correct? Okay, so this clear, right? So you found the first island. You have added the first cell. For example, this cell you added into the priority queue with a distance 0, correct? Because it is part of the island, so it has distance 0. This is the BFS now. So queue is not empty, right? So this is our BFS starts basically. Okay, so we'll keep looping in this while loop until the queue has some elements to process. You will remove the temporary node here from the queue. You will always get the node which has the least distance because this is a priority queue, correct? And we have implemented the comparator for that, correct? Okay, now we are going to go in 4 directions from this current cell that we removed here, right? Okay, so how you will calculate the new cell, temp dot I plus direct dir of I and temp dot j plus dir of I plus 1. So you will get new cell, right, in 4 directions. I shown you, right? These are the 4 directions. So this cell you will get, then this cell and this cell. So these are the 4 directions connected cell you will get in this case, right? Now you want to make sure that this is actually a valid cell, right? So valid cell means it must be within the boundary of the matrix. So we are checking that here. So new row is greater than equal to 0, new row is less than grid dot length. So and new column should be greater than equal to 0, new column is less than grid 0 dot length. It means that this is actually within the boundary of the matrix, so that is fine. Also it should not be having a -1. It means that it should not be already processed cell, right? Correct, because we don't want to process the cell again and again, so we'll only process it one time basically, right? So that's how we'll keep track of that. Okay, now if it is 1, if this new coordinates that we found here, right, new row and new column, if that coordinate is a 1, it is a land cell. So we will check the temporary cell's distance. If it is 0, right, it means that this new cell is also part of the same island. I am repeating this. If your current temporary cell distance is 0, right, and you are actually visiting one cell, it means that this new cell is also part of the same island. For example, from this 1 to 1, this is same island basically, correct? From this 1 to 1 same island, 1 to 1 same island. How we identify it's the same island? Because the distance is 0 basically. That's how we identified that it's the same island, correct? Distance is 0. If distance is not 0, it means that it's not actually a part of that island. So you have to, so it means that you found out another island. Because how you identified it? Because it's a one cell, it's a land cell, and your distance is not 0, correct? So it means that you found out another island. So you will just have to return temp.distance. For example, when you reach from this 0 will have a distance 3, correct? Distance 3. Why distance 3? Because this is distance 1, this is distance 2, this is distance 3. Now when you reach here at this one, right, you are seeing a cell which is a land cell, and your distance is not 0, right? Your distance is 3. It means that this is another island basically, correct? So you will have to return that distance. So that's what we are doing here, correct? This one will happen if it is a land cell which is 1, correct? But it is possible that it may be a water cell, correct? Like 0, like this basically, right? When you go here, this might be a 0 cell. So you have to add that cell into the queue, correct? So you will add the new cell into the queue. You will use the new row and new column coordinates. The important thing is your distance will be increased by 1, right? The current distance, which is temp.distance plus 1. This plus 1 is very important, because your distance will be increased now by 1, correct? For example, here your distance will become 1, right? Let me remove it. For example, when you go to this 0, your distance will become 1. When you go to this 0, your distance will be 2. When you go to this 0, your distance will be 3, correct? So that's what we'll do, right? And then you have to mark that new cell as a -1, because you already processed that cell once you added it into the queue. So grid of a new row comma new column is equal to -1. So we are making it as a visited cell. So this loop, while loop will keep looping, keep processing the elements in the queue until it reaches a second island. Once it reaches a second island here, then whatever distance of the previous cell which actually made this transition, right, is the number of zeros that you have to flip to make to 1, so that you can build a bridge and connect those two islands. So that's what we are going to return here, right? The temp.distance. So this is important, right? This means that we reached the second island. If you never be able to reach the second island, you will come here, you will return -1. So it's actually not possible, right? So we will now run this code and make sure it gives us correct answer with these test cases. For the first test case, we are expecting 1. So these are another test cases, but we'll try all these test cases. 1 is the correct answer, as you can see. For the second example, we are expecting 2, and we are getting 2, which is a correct answer. For the third example, we are expecting 1. We are getting 1 correct answer. Submit this code now to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 34.5% faster on the performance side and 22.5% on the memory usage, which is a very clean and good solution to solve this coding problem. This one very popular, frequently asked Microsoft coding interview question on Leetcode 934 shortest bridge. So I hope you like this solution. You liked how we have used the priority queue approach, and how we have actually solved this problem using BFS and queue. So I'm going to add this Java code in my GitHub repository and give you the link of this Java code so you can check it out. There are lots of other important algorithms and Java solutions already implemented and available there for you in the GitHub repository. So don't forget to check out the other Java codes. They are important solutions. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview preparation. The name of that playlist is Leetcode and Leetcode Solutions. 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by many big companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, Netflix, many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them thoroughly. If you go through all those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of different varieties of problem solving. So do check out the solved coding problems. The name of the playlist is Leetcode and Leetcode Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems, to help your practicing purpose, we have created 3 other playlists for you here. The names of those playlists are Code Forces, CodeChef at Coder, Code Forces, CodeChef at Coder. More than 800 different varieties of problems are here to help your interview preparation and learning process. If you like today's solution where we have used priority queue and this BFS based approach to solve this another frequently asked Microsoft coding question on Leetcode 934 shortest bridge, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people, so others will be also able to watch and learn from this video. So do subscribe to this channel, share these videos with your friends and colleagues, so they will also learn how to solve these kind of problems and how to implement their solutions in Java. Click on the bell notification icon button right away so you won't miss any important postings from this channel. On this channel you will find lots of solved coding problems which are important varieties from interview perspective, that includes graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are also lots of important data structure questions available for you on this channel, including stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All those are important problems, so make sure you go through all of those problems, understand them very well. It will definitely help you learn lots of new techniques also and new things from this channel. If you are a fresher, junior level developer planning to take Java interviews, there are lots of Java related videos we have created for you here. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries where you have to use different database concepts like joins, aggregate operations, group by and having clauses, different where clause conditions. Everything is available on this channel. So those solved problems are available with explanation, database tables and SQL queries. There are videos that discusses recently asked questions to the freshers about Unix, like Unix commands, Unix utilities, shell scripting questions. All are here to help you in your interview preparation and learning process. If you like the videos on this channel, if they are helping your learning process, you are learning new techniques, more problem solving along with Java programming and coding, then please do leave your feedback, your messages, your comments below these videos. Your feedback, your comments and messages are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos. So do leave your messages below these videos. Tell us how the videos are useful and helpful for you in your learning different techniques. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then please mention those topics as well in the comments section so that we can create those videos for you here. If you haven't already checked the playlist, go ahead, check it, check the playlist on this channel right away. The problems are categorized for you based on the problem types. For example, the different problem type playlists you will find on this channel includes dynamic programming, arrays, linked list, graphs, matrices, binary search trees, sliding window algorithm, Dijkstra algorithm. So do check out all those different playlists. Those are important playlists. They will give you good preparation for your interviews, and you are also going to learn lots of new techniques and new things from this channel. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.